Alright, this is Unit 1 FRQ test corrections. It is past 12, but hope this doesn't get too deducted. I've been. Anyways, let's get started. No more blabbering. So, we're given x equals 0, these are rest. Truck has constant speed, car has constant acceleration, meaning speed will be linear, increasing. And then also, they meet up at t equals, or at time td, at position x equals d. Okay, so 1a. They ask us to graph and label the velocities of the car and the velocity of the truck as a function of time. So times vt, or I can just write v as well. Don't want to get confused with the truck. Vt, truck has a constant velocity, so that means straight line. Car has a constant acceleration, and if we integrate that, then that means, or not integrate, if we derive that, then from acceleration to velocity, that means the constant will turn into an x value, which means it will be a linear graph. It will be a car, and they will meet up at some time td over here, past the point where they have equal speed. Okay, and this will be v of t, and this will be 2v of t, since the acceleration must be double, or not acceleration, the speed of the car must be double to catch up to the truck, because down here in the graph, if we count out the little units, that's when position is the same, and that's what happens when it's double. And area under the curve, because that just means integrate, which gets our velocity to position. Part B. Two students are discussing how the speed compares to the truck when both vehicles are in front of the house. So student 1 says, so part B, they want to prove, or not prove, but state which parts of student 1's are correct. So student 1 says distance traveled by car and truck is same, and time is the same, so they must have the same speed. So although yes, distance traveled by car is equal to distance traveled by truck, and the time is the same, so time of car equals to time of truck, with t, both these t equals, the sub t's are truck, is incorrect to say that they must have the same speed based off this reasoning, because they have the same speed at this point over here on the graph, and they have not met up here. It is somewhere in the middle or before the middle, or just some point in between x equals 0 and x equals d. That's when their speed is the same. Okay, so yeah, that just disproves half of what student 1 says and proves half of what student 1 says to be true and untrue, or false. Oh, didn't mean to zoom in. And oh, I forgot to do errors. Okay, wait. Oh, it's not too late. Please forgive me. So, error for 1A. I'm so sorry, Mr. McClure. Error for 1A. What I did was I did the P versus T graph, even though it clearly stated V. And it looks something like this, where this is a car and this was the truck. So I integrated what they given us, and this is what I got. And yeah, I'd still do put TD somewhere over here, right, where the exponential thing meets, or parabolic graph meets the, well, not meet, but yeah, not meet. I never said meet. So yeah, I graphed the P versus T graph when they clearly stated to graph the V versus T graph. I just went off prompt. Maybe I had too little sleep that day or something, but yeah, my error was I graphed P versus T graph instead of V versus T graph. And part B, I had no errors. I got that correct. I did state that to student 1 was correct about the first part and incorrect about the second part, and did give valuable reasoning. Or not valuable, but what's that word? I don't know, but good reasoning. Valid reasoning. New page. So now B2. B2, wait, where is it? Right here, yeah. What does student 2 state is correct? Or what parts is correct and what parts are incorrect? So, student 1 states, I don't see how I can pay to student 1's claim. The car catches up to the truck, so the car has to be going faster, and that is true because it stated the initial velocity, so VI of the truck is greater than VI of the car. But then the car had a constant acceleration, so that means the velocity was constantly accelerating to a point where even though the truck was initially faster and got farther than the car would eventually speed up to a point where it is faster than the truck and they will meet. So at the point that they meet, the car must be faster since there's an increasing velocity for the car and the velocity for the truck stays the same. So that's my reasoning, and I did state that too, but I worded it differently. I just said that the car had a constant acceleration. That means it has a linear growth, which is greater than the truck's constant velocity. Linear growth in terms of the speed, of course, slash velocity. Alright, so no error for this one as well. Did I write no error for that one? For the one above? No error for this one. I'll just draw a little blue arrow just in case like you skipped the video or something. Part C. I did not get this one wrong, but before I get to that, let's solve it first. Derive an expression for acceleration of the car. Express your answers in terms of d versus t. Nope, this is the wrong one. Here it is. Okay. So we have these three equations and we have to solve for acceleration. So we're going to use the bottom one because we know v of x of 0 is 0. So that makes it easy. And then we also know that x minus x of 0 is just x because our initial x is also 0 and x is d. And we need it in terms of d and vt. And this also has vt. So that is quite can't think right now. Fortunate. That's probably the wrong word for it, but anyways, let's write that formula down. V of t squared equals what? V of x of 0 squared plus 2ax times x minus x of initial, right? Yes. So we can just cancel this out because that's just 0. So v of t squared equals, and we can just cancel this out because we know that's 0, 2ax x, and we need in terms of acceleration, so a of x equals v of t squared over 2x, and x is equal to d, and vt is equal to 2v, or 2v of time, since right here, if we integrate it by calculating or counting up the units below the graph, and if we graphed it correctly with the correct slope, then we know that at TD, velocity is 2vt, or 2 times the truck. So it'll be 2vt squared over 2d And we can also simplify that further. So we just square this, and those twos cancel out, or not cancel, but the bottom one cancels out, and then what's left on top is 2vt, like that, a little prettier, t squared over d. That should be the correct answer for C. And my error, let's make a new page, it's taking up a lot of space. C error. So I did use the correct formula, and I did plug in everything quite correctly, except let's just skip all the math and go down to the a of x step, because I already showed my work for that. A of x equal to vt squared over 2d. I did not recognize that v of t is equal to 2vt, or that v of v to respect of time is equal to 2 times the velocity of the truck. So I just left it in this form, and that is not very correct. So that's why I got it wrong. I was really close, but I got it wrong regardless. I at least got some points. Part D. Oh, why am I looking at paper? I should look over here. To determine the time at which the speed of the car is equal to the speed of the truck, so just the midpoint right here. So that's your answers in terms of VTD, or just T of D, and then justify your answer. So I did get this one wrong, but let's solve it first. So we know from our previous problem, a of x equals v of, not this, I'm looking at the wrong one, 2v of t squared over d, and then we use the formula, let's get a formula sheet. We would probably use the first one, because we know the initial is 0, and it just makes it a lot easier. And we just isolate time. And we need it in terms of TD, and TD is there. Or it's not there, but we have to substitute it in later. So V of, what does that say? X. Well, our X is T in this case, so we just do V of T equals, let's write the whole formula down first. V of X initial plus A of X times T. So this just is 0, because we know that for a fact. And then over here, we're solving for time. So v of t squared over ax equals t. And then, no, this is not squared at all. Think about the wrong formula. And then, we substitute back in, since we need it. Substitute a from over here, since it's asking for us in terms of TD, and our a over there TD. So let's start a new page. V of t, substitute back in, which is 2vt squared over d, 2vt squared over d equals t. Okay, and then we can just simplify this. So times d over 2vt squared times d over 2vt squared. Squared cancels out. That's what d over 2vt equals t. And then I think we can simplify this further, since Vt is equal to d over td, as seen up here. Where is it? Vt equals d over, let me write this. D over td. Well, we can just look at a graph. I don't think I necessarily graphed it out, but Vt is equal to d over td, because that's just the formula for velocity, distance over time. So d over 2 times d over Vt. And d's cancel out, you multiply by 1 over d, right? Yep. And then you're left with, well, we can multiply Vt as well, so maybe a little easier. Well, not Vt, that is Td. Let me erase that, I'm sorry, I wrote wrong. Td, so it's Td over 2 equals T. That should be our answer, right? Let me double check. Yep, that's our answer. And justify. So the speed of the car is equal. So to justify this, we can just say that we can integrate the graph of the V versus T graph of the car and the truck, and we find that at TD, the car is 2 times greater in speed. Or not 2 times, but that's when at TD, that's when the equal. So that means at half, it must be halved, because it's the half point, so it must be half, because it's 2 times, so then 1 times would be halved. So TD over 2 is equal to T when the speeds are the same, because we just take this divided by 2. And then error part D. My error was I just didn't know where to start, because I already got C wrong. I was very unsure of that, so let's write down what I put. So V of C equals Vt question mark, and also A of X equals V of X, which is completely incorrect. But then I started integrating, because A of X, the derivative of A of X is well, actually, we could probably ignore this, because I just wrote it down to get my thoughts in place. I didn't even use it. Here. There we go. That's proof. I'm not lying. So I need to erase this too. We don't need to know. We just need to know what I tried to do. So what I try to do is integrating A of X. Oh, what I put there is A prime of X equals V of X. So this is just something from calculus. I don't know why I try applying that here when we given no formula. So I wrote V of X. Wait, since A prime of X equals V of X, that means V of X equals to a prime of the previous formula, which my incorrect one was Vt squared over 2d. So when I use quotient rule, it was Vtd minus 2Vt squared over 4d squared. And it's simplified to Vt equals 2d times d minus 1, which was of course the wrong answer, and it wasn't even what I was looking for, which is T of d over 2. And I need this in terms of T of d, and I just didn't know how to put this in T of d. And out of desperation, I just wrote they probably will meet at halfway, so I just wrote TD over 2. And guess what? I got it right somehow. But that doesn't change the fact that I'm still here doing my test corrections because I got half of it wrong. Because although I got the answer, that I don't think I justified correctly, and I did not show the correct work required. I just wrote this out the blue, which is not okay for FRQ. And yeah, I think that pretty much wraps up my FRQ Unit 1 test correction. Thank you for tuning in.